Thank you. Hello, everyone. Welcome. Today I'll be presenting breaking smart bank statements, how to read a bank statement without a password. This will be the agenda for today, a little bit of context, the analysis of the file, analysis of the JavaScript, a brief talk about RC4, a demo, the analysis after the fix, conclusions, and Q&A. So who am I? I work as a security researcher at Trustwave Spider Labs. That's the shirt on. I previously worked as in the offensive side of security as an ethical hacker, and before that I worked on the defensive side as a network security monitor. As I really like web attacks, all web related, like defense and offense on them. Denial of service is also a very, very interesting topic. How can a few people or a few servers can bring huge things down? That's really interesting. If anyone is interested, we can discuss both of them for hours. Other things that I really like and we can discuss for a lot of time are dogs and tacos. Like, I can definitely talk about them for a lot of time. There's my Twitter handle if someone follows me. And context. So this research, I did it last year. It's have here, most of those banks are really, really big because we only have like 20 banks in the whole country. Like 10 of them are the big ones and 5 are really big. This is the disclosure timeline. So I disclosed this to the Spider Lab Research Intelligence team on March 21st last year. The next day, they contacted the vendor. The intelligence team is an internal team. There's in Spider Labs. They help us with all the responsible disclosure. They help us contact the vendor, do it properly, and help us as researchers with a lot of time. The vendor responded April 30th. And July 19th, they confirmed, well, they told us it was fixed, and I took a look and it was indeed fixed. Who's the bank? The name is Citibanamex. It's one of the largest banks in Mexico. According to Forbes, Mexico is the 3rd biggest bank. And it's part of Citigroup, which is one of the biggest groups in the world. In Mexico, it's possible to get your monthly bank statement via email. Usually you get, like, there's the email I receive every month, more or less. I get it. If you see closely, there's the attachment in the bottom. And there is the Mexico Banking and Security Regulator. That's part of Mexico Central Bank. They have legal faculty to regulate banks. They have a very big document, which the name is Circular Única Bancaria, which is like a legal precept or a legal standard. So it's not exactly a law, but it's really something important. Like, they must follow that because the institution has enough power to tell how the rules are. Like, if you don't follow that big document, they could even close a bank. Like, it has never really happened that I know of, but they have enough power to say, like, a bank, like, you can no longer do business in Mexico. So every bank really take this serious. In that document, Title 5, Chapter 10, Section 2nd, Article 313, it's a very big document. It says that banks can send bank statements via email, but security mechanisms must be in place, so any unauthorized third party must not read it. And it also states that the bank statement must be encrypted. It's a legal document, so it's not very technical, but there is a requirement to do it and to do it properly. So this is really important. In Mexico, most banks send your bank statement either a zip file or a PDF. Both are encrypted. And this started like 8 or 10 years ago. Every bank started to do it electronically. It's cheaper and it's supposed to be safer and it's easier. Citibanamex uses 2 types of bank statement: the encrypted PDF, which is used for most accounts like debit accounts, payroll accounts, etc., and the smart statement. They only send that one to like the highest brands of credit cards, the Gold, Prestige, and beyond. They had these frequently asked questions, and it's really fun, like if the smart statement is safe. And their official answer was like, yeah, it has the highest security protocols worldwide, which is why it's just as safe as your PDF account statement. Every time I read things like highest security protocols or worldwide or military grade encryption, that's definitely something like, as a researcher, you should take a look. You know, you should start digging, like, why do they say highest security protocols? Like, how are they so sure? I'll start analyzing the file. This is the HTML file they send you as an attachment every month. It's a very simple file, so you just open it and it says, welcome, your name, last 3 digits of your credit card, please input your password, a password field, and a submit button. If you put an incorrect password, it says, password is incorrect, try again. If you put the correct password, the whole page changes and it says like, welcome to your smart statement. Are you ready for an improved experience with your bank statement? And then there's all the bank statement. I think that's also a little bit different because the bank statement has a lot of private information. Like there's your full name. I cover my name, but there's your full legal name. There's your full address, there's your fiscal number, and there is also the credit card number. All of that is in that file. Also, like all the money you move, where do you spend it, blah, blah, blah. So this kind of information, you definitely don't want anyone to see it. That's why the law requires that there are important security mechanisms in place. I start looking at the file. It's a simple HTML. It's around 2 or 3 megas. Depends on how much you spend that month. It contains a lot of JavaScript, more than 90%. There is a little bit of styling and very, very few HTML. That HTML is just the thing that we saw 2 slides again, that it's welcome and input text, and that's it. I opened the file with a text editor and I saw a lot of unreadable data. Like, if you see the one in the right, that's like a lot of data like that. There is no distinguishable format. So my next step was to start analyzing JavaScript. Like more than 90% is JavaScript, there must be something fun in there. And it has a lot of variables. It has 31 functions and a lot of variables. Some of those variables are very easy and it's very easy to relate. They have something in common. They have a very similar name, like hexscript 0, hexscript 1, hexscript 2, hexscript 3, etc. So there's definitely something going in there. One variable is very interesting. The name is validate password. And after understanding the JavaScript and the flow, the logic is the following. The user submits the password, then a SHA-1 hash is calculated, and that one stored as hash type password. A second hash is obtained and it's compared against the variable validate password. If they are equal, they start decrypting the message, passing as a parameter the first hash. So this is the first time I see a flow like this. It's really interesting because they get 2 hashes. They don't do any salting, so that's like a little bit of a warning sign. Like there could be an attack in here in terms of a rainbow table or something. But I mean, I didn't consider it strong enough to say like this is just bad. Like just the approach is interesting. They get 1 hash, they do another hash, and they compare it. And clearly, the next step will be to follow what does the function desync does. It receives as an argument the first hash. So if we look at the function, it's basically like 2 steps. The first step is they create an array and they push the result of the function decrypt, and then they replace the content of the window, which are the last 5 lines of code. If we see with a little bit more detail, we see they're calling the function decrypt a lot of times, always using as the first argument hash type password, which is the SHA-1 of the password the user submits, and the second argument is the base 64 of hexscript 0, hexscript 1, hexscript 2, etc. So the next obvious question is, what does the function decrypt does? And that's the function decrypt. I remember when I was doing this research, I put that function like in my desktop. I start analyzing a lot. At first I didn't know what it was. Like, I literally print the paper and I was just looking at it. Then I asked some guys in the SpiderLab research team, like, hey, do you have any feeling or any idea what this function is? And one guy, Dan Katz, thanks Dan, he told me like, hey, it looks like RC4, why don't you start digging on that one? And it does look like RC4. The only significant difference, or the only real difference, is line 18. They're missing the +1 operation. If anyone knows cryptography and knows what does that affects the algorithm, I'll be really happy to talk about it, because I didn't see anything in practice that it changes, but I'm sure there is a reason to have that operation. RC4 is a stream cipher. It's very old, it has more than 20 years. Today it's not considered a strong encryption algorithm. And the most important is it receives 2 arguments. Like, the first one is the key, the second one is the encrypted text. And if we remember from the previous slide, they're using the same key a lot of times. For all the messages, they're using the same key. That's really bad. You should never ever do that in any stream cipher. Let's talk a little bit about RC4. It's an old algorithm. There are some attacks, but they're not very simple. Like, they usually require you have a lot of packages and a lot of messages in order to do this attack. There's like all the attacks on web are because of this. There's the birthday attack. There are a lot of other attacks, but it requests that you have a lot of messages. This was definitely not the case, because you only have 1 bank statement or 2 bank statements or whatever. The important thing is that in any stream cipher, you should never use the same key more than once. Here they're using it about 30 times to encrypt 30 different messages. And we also know that the desired output is always an HTML, because if we remember the correct flow, once you put your password, it will show you an HTML. So we can do a known plaintext attack. Any stream cipher, in particular RC4, for each byte, the encrypted text equals the key stream XOR the plaintext message. That equals to the key stream is equal to the encrypted text XOR the plaintext message. And this will be the base of the attack. So that equation, especially the second one, is really important for us, because once we have the key stream and the encrypted message, we could also get the plaintext message. We have the encrypted messages. It's split in about 30 variables for our convenience as an attacker. The next question is, can we get the plaintext? And it looks like we can, because they're splitting the message, like the whole message, in 30 little messages. And since the result is an HTML, the first part of the message will always be the same. It will always have the HTML tags, the head tags, and since the idea of this bank statement is to have all these like fancy functions of you click something and you get some graphics, and if you click another, they order the data by spending blah blah blah. They use JavaScript for that. So every bank statement will have the same JavaScript functions in the same order. This is very beneficial for us. So the basic idea behind the attack is we will have the plaintext, the first part of the bank statement as a plaintext. Then we will get the key stream with a simple XOR of the plaintext and the first encrypted message. Once we have the key stream, we will just decrypt the rest of the messages using the key stream. So now we go for the demo. I already prayed for the demo gods, so I hope they're happy. I will show you 2 files. One is my bank statement, and the other one is the bank statement of a friend, because when I did this research, I was like, my bank statement is good, but I also know the password, so it's like not the best attack. So I call a couple of friends and say like, hey, do you have a bank account with these guys? And 2 of them said, yes, I have. and I asked for their statements, but I didn't ask for their passwords. So I literally have no idea of their passwords. And yeah. Okay. So here's this is the result of opening the file. If we put any password, it will say incorrect password, try again. So we will use our exploit. This is the basic exploit I put. It's a basic XOR function. This is where the magic happens. And this is my attack function. It's a very simple XOR of the key stream and the encrypted text. This is the first, this is the plaintext of the message. And here is, I get the key stream. Here I get the exploit function, and this is just some small code to hide my data because I don't want to show my credit card and stuff. So I copy the XOR function. And the attack function is this one. So now I get the key stream with an XOR of the plaintext and the first encrypted message. And okay, so this is just the attack function, and then a little bit of hiding and rewriting. So and there it is. You can see the bank statement. So in order to be a full demo, I have to test it with another file. This is the file of someone like a friend, but I have no idea what their password is, so I try something random. It doesn't work. And I use the very same exploit. So I define the XOR function. There you go. And I'm using the same plaintext because let's remember, like, this is an HTML, and the same function, the same part of the HTML will be the same for every user. This is what we will use as the base of our attack. And here I'll just put another name because this is not my bank statement. And that's it. We use the same attack and we open two different bank statements. So, like, yeah, there you go. If we look into the details, like the amount of credit and then expenses, etc., are different because we're two different people, but I think it's not required to go into those details. Also, I'll show you quickly the content of this HTML file. So this is what I show in the first slides. This is the file. It's all encrypted text. We got no idea of knowing what's in here. And there's very little HTML and very little CSS. So most of the things is this encrypted text. And continue. So once the bank notifies us that this was fixed, I start analyzing the new file I receive every month. And it looks like they did fix it. Like right now they're using Crypto.js, the version 3.1.2. They're using the specific modules of AES and SHA-256. The decrypt function now uses AES, so that's good. That's way better than using RC4. Before decrypting, they're putting all the encrypted messages together and they're joining the text before decrypting. For the hash, they're using SHA-256. It's better than SHA-1. It's a little bit harder in terms of computing, so for brute force attacks, that'll be better. And they also, it's a good idea, they changed the hash, because if they will leave SHA-1, that will be an issue, because they will give you the key to the previous messages. All of this disclosure was transparent to the clients. Like, as a client, I didn't get any message like, we're changing the security or we're changing anything. So it's good they did it this way, because they help their customers be safer and they didn't break the security in the meantime. So a little bit of conclusions. I think I run a little bit fast, but yeah, you'll have more time. Every time you roll a new security product, it's always important to have a security review. Like, if you're in any business and management or leadership decided to roll a new product, try to be like strong on the idea of having a proper security review, especially if your product has an obligation to fulfill certain laws or certain precepts and you are required by law. If you're doing complicated things like cryptography, hire a specialist if your team doesn't have the proper skill set. Cryptography in general, like, I think it's harder, especially for developers. Like, I mean, if you are not a cryptography expert and you Google stuff, you may read some stuff online that's not 100% true, right? Like Stack Overflow and similar websites may have an answer that kinds of works, but it's not the safest. I mean, here they did cryptography and it kind of worked, but it wasn't very safe. So that's why you should hire specialists. Hire people that really know their cryptography. There are a lot of smart people in the world. In this city right now, there's a lot of very smart people, so you should hire them. Always use cryptography algorithms that are considered safe. Never use all algorithms. Never use algorithms that are, like not the best at the moment, because that will be an issue. If not an issue today, definitely an issue in the near future. Never ever roll your own cryptography algorithms, nor implement a cryptography algorithm differently. Like, unless you are designing a capture the flag challenge, don't do this. Like, especially for production environments. Never use the same key more than once in a stream cipher. This is cryptography 101. But as a security people, we must have this very clear, especially because sometimes we check the work of developers and they're not security people, and that's good. Like, they know how to do their thing and they know how to do it very good on their things, on their side. They do amazing code and they don't know our side. So we have to help them get this side. We have to give them these very few tips, like never use the same key more than once in a stream cipher, use good encryption algorithms, etc. If possible, especially if you work in a bank, try to have a simple, safe, and clear way of communicating security issues. This is something that's unfortunately not as easy or as common. Like, I've done a lot of disclosure. Thankfully, the SpiderLab research intelligence team has helped me. They're an amazing team. But I know that if they weren't on my side, this will be really hard. Like, this disclosure in particular, it was hard for them because the bank doesn't have like a very simple website like, hey, give us a message here if you find anything. Most of them don't have it. So if you work in an organization, like, please check if you have a way to receive bugs. And if you don't, start doing the process and start talking with the people, especially with leadership or management. So you start getting this process and you have a clear way of getting things. There's a blog post in the SpiderLab's lab blog. If you want to read it, it's basically the same, but a little bit shorter. And as a security researcher, I also have a few tips for the people who do research. Every time you get a new product, every time you see something new, like, try to hack it. Even if you say like, oh no, this was made from this big company, they should definitely have some good security in there. Try to hack it, read the code, understand what's going on. you may be surprised. I was very surprised. Like, this is a big bank. They have millions of customers. I was pretty sure they did like their proper review, the proper security review, but at the end, I also understand there's always a business need to release faster, to release cheaper, to release like code generally goes like very fast. So that gives us an opportunity as security researchers to find fun stuff. And don't try to do stuff that's illegal. Also be careful with that one. And questions? Does anyone have any question?
Do you have any idea how much back and forth Spider Lab have to go with this bank to get it done?
Yeah, I remember I sent this to the intelligence team, and like the next day they told me like, okay, we've already sent an email, and I go with them like a week later and I said like, hey, do you got any news? And they told me like, we've emailed a couple of people and a couple of public emails, but got no answer. And then I said like, okay, let's wait a couple of more days. They sent more emails and they got no answer. So at some point they told me like, they're not answering. Like, we don't know if we're hitting the proper people. We don't know if we should go to city. We don't know what to do. So I asked a former colleague, and she worked in city for a while. And I said like, hey, I got an issue. Do you know who I can talk to? And she referred me to this person. And she advised me like, this is not the guy who will solve your issue, but at least he will read it and he will know with who to forward it. So it was definitely a few emails like going back, going forth, and there were also some NDA agreements. So they were like, the intelligence team did an awesome work, but I think this process was too hard. Like, if I would do it personally, I wouldn't finish, because it's very exhausting, and it's hard to communicate properly with certain institutions.
Okay. And compared to other customers, how hard was? Have you ever had? Okay. So compared to other customers, how difficult it was? In the sense of the timeline, talking to people. I'm assuming that other companies are more open to these kind of disclosures or fixing these problems. And probably this is just like bureaucracy, normal bureaucracy in a Mexican bank. So I'm just curious to know how difficult it can be for, let's say, a manufactured company or another kind of industry.
That's a good question. Like, this is the first issue I find in a bank on my own. So like, they're not expecting the report. So that's always a different treatment. But I have found a couple of issues like in software, like VPN software, and it got a very like a fastest response, like very, very fast in comparison, because when they do software, like I think it's easier to patch. And this one, I can imagine that it had to go through a lot of teams, and a lot of people are in this decision, because it's a bank and it's a big, big bank, and there's a lot of decision making, and there's so it was like very slow in comparison to others, but in general, I think 2 or 3 months is a very good response time for a bank in Mexico.
Okay. Yeah, last question, sorry. So in your opinion, how is Mexico in the bug bounty program? Like, have you seen many companies actually adopting this practice, or it's just something that no one cares?
My opinion is that it's an area for improvement. So, I mean, I haven't really seen big companies do it. Hopefully in the next years, there will be more programs and more conscious in that topic, but today, no. For this research, I got nothing from the bank, not even a pen or something. But I got the authorization to talk about it, so that's good.
Thank you.
Thank you.
So for using the known plain text, did you just open up your own bank statement with your own password and then just extract the first chunk? And like, how much of the plain text did you need?
That's a very good question. So what I did was opening my bank statement with my normal password. I grabbed a little bit more of the length that my first encrypted messages. I mean, depends on how big your bank statement is, how many messages they they split it on. Some months I got like 28, some months I got like 33 messages. So I use like the largest one. I count the bits. I use the one that's largest and a little bit more. And the XOR function I'm using will take the, like, whenever it's one of both messages stops, like if one message is larger than the other, it just stops the function in there. So it's better to have like a longer key stream and not use it instead of missing some bytes and having a strong result, like a bad result. And I did use my bank statement, like my first one, and it breaks all of the bank statements of that month. There is also a little situation, and that's the reason. Well, I didn't publish this tool because of two reasons. One is I think it doesn't really help the good people, because that's the theory of breaking it, but you don't need to break something to see like it's really like you're able to break it. And number two, I saw like 2 or 3 different versions. I think they fixed some bugs, like production bugs. So at some point they changed the JavaScript libraries. The attack's still able to work, but as a tool, you will need about 2 or 3 versions, and you'll need to do some fancy things to detect if they're using version 1 or version 2, etc. But yeah.
Okay, thanks.
A quick question. You mentioned that there was a line of code missing from from part of that algorithm, and I was wondering, have you determined, is that a bug or is that a feature, something that they didn't?
So this is the RC4 function they're using, and it's just in this line, the algorithm you find in Google or in Wikipedia or whatever, the original algorithm, here has some parentheses, and it says +1. This is also a proprietary algorithm, so there is no RFC or any like official source of the algorithm. This is like a funny story. I guess lots of people in this conference live the story. I didn't live it. But this algorithm was leaked. So like the leak algorithm is the one we know as RC4, but like the official one is you have to pay for it. And this is just the line that's changing. I did a lot of thinking, and I asked some people, and there is no like direct effect on negative or positive, but I think there must be something somehow. So if anyone knows the answer, like what does this +1 does here, that will be interesting. It's also more of a thinking exercise because this had a bad implementation. So like there was a bigger issue than missing a line in the algorithm. It's a bigger issue that they did it improperly. And the way they fixed it was using a different type of algorithm, instead of stream cipher, they're using block cipher. So yeah, there is no solution on that one. Like no, it won't really have an impact to put all these hours, but it's a really fun challenge. If anyone knows, I can get you some stickers. I got pictures of my dogs in stickers. Does anyone have another question?
Thanks. It was really interesting, especially when I'm from Mexico too. So knowing this brings some concerns. Do you know if any other banks are following the same practices, and like Scotiabank or any other ones? Have you ever looked on those?
That's an interesting question. I don't have bank account in all of them. I have like in some of them, but I have friends who have banks in most of them, and they all tell me they either send their bank statement in either an encrypted PDF or an encrypted zip file. Also, my friends don't like to share their bank statements with me for some reason. Like, just give them for free and I won't do anything, but they have their doubts. And that's like using a smart statement. I've only seen Citibanamex, but the idea of using encrypted PDF and encrypted zip files in all the country, it's a very interesting topic because I've talked with some people and it's not the safest approach. Like every year it's easier to brute force. So at some point, all of the security will be outdated. So that's also a very interesting place to start thinking about it. There are a few banks, to be honest, that they do it correctly. I think American Express is like kind of a bank, and they only send you an email, which I think is the same they do here, like, hey, your new bank statement is ready. Log into the page and download it. That's a little bit of pain for the user, but it's way, way safer because you cannot brute force that one. I mean, the window of opportunity is very, very close, very small.
Yeah. I have Amex as well, and they have a very easy report spoofing emails metric. So.
Yeah, speaking of Amex, I also have them as a bank, and they're the only ones I've found that have I get phishing emails from fake Amex, and Amex has a very clear way to report those emails. You just forward it to a certain address, so I was pretty impressed with that as well.
Yeah. Some of them do a little bit better jobs. Well, thank you everyone. Hope you enjoy it.